Hello friends, you are most welcome to my YouTube channel NEPChem Guru. Um, this channel is specially focused for chemical education, chemistry education, and today I am going to talk about the mole concept. This mole concept is very important for chemistry student and chemistry people. So today I am going to talk some concept about the mole, and this is called mole concept. First of all, you need to define the mole. What is the mole? You know that mole is the fundamental unit of the amount of substance. Chemists often use the concept mole for measuring the amount of substance. So, a mole of chemical species may be defined as the amount which contains same number of particles as there are atoms in 12 gram of carbon 12 isotope. So how much number of particles, how much number of atoms 12 gram of C12 isotope contains, that much number if contains in a substance, then that is called 1 mole. So 1 mole of any substance, any chemical species is defined as the number of particles that is equal to the number of atoms that is contained by the 12 gram of carbon 12 isotope. So friends, mole can be used for each and every chemical species like atoms, molecules and ions. It is even used for electrons and protons. The concept can be applied for different kinds of chemical species and its calculation. Now experiment has proven that 12 gram of carbon contains 6.023 into 10 to the power 23 carbon atoms. So uh, 12 gram of carbon equals to 6.023 into 10 to the power 23 carbon atoms. So this number is found by the experiment. So this number is called, this magic number which is called 6.023 into 10 to the power 23 carbon atoms is called Avogadro's number. So 1 mole of any substance always contain Avogadro number of particles. For example, if you say 1 mole of hydrogen molecules, then it contains 6.023 into 10 to the power 23 hydrogen molecules. Similarly, if you say you say the 1 mole of carbon dioxide, then it contains 6.023 into 10 to the power 23 molecules of carbon dioxide. And if you say that there is 1 mole of electron, then that is also 6.023 into 10 to the power 23 number of electrons, like this way. Okay, 1 mole of any substance constantly contains the same magic number of particles, that is 6.023 into 10 to the power 23 carbon atoms. So chemists often use the term mole, and the student who is learning chemistry must know about the mole at first. So today I'm going to talk about the concept of mole, and here you can see in the figure, mole is always in the center. This mole can be related to four different terms like mass of atom. For example, if you have mass of atom in gram, then you can easily calculate the mole by dividing with atomic mass. So mass of an atom in gram, if you are provided mass of atom in gram, then you can easily convert that into mole, but for that you divide by atomic mass. So I can easily say that mole equals to mass of atom in gram divided by atomic mass. Okay, this is one of the simple formula. How do you convert atom in gram into mass of atom in gram into mole? You just divide by atomic mass of it. And in reverse, if you want to convert mole into mass of atom into gram, then you multiply by atomic mass. So for atom, if you talk about atom to calculate about mole, then you have to know the atomic mass of it. And the atomic mass, either you multiply if you want to change from mole into mass of atom in gram, uh, and in reverse, if you want mole from the gram of atom, then you divide that gram by atomic mass. So we can easily convert the mass of atom in gram into mole. Similarly, if you have mass of molecule in gram, for example, you know the molecule like carbon dioxide, water, calcium carbonate. The compound has got molecules, its molecules. So in the case of compound, if you have a gram, its mass. If you are provided the mass of compound or molecules in gram, then you can easily convert it into mole. So how do you convert that into mole? You can easily see by arrow. You divide by molecular mass. Okay, for example, if you have carbon dioxide, 88 gram of carbon dioxide, suppose 88 gram of carbon dioxide, how much mole of this carbon dioxide is? So then you just divide by 44. 44 is the molecular mass of carbon dioxide, that is 2 mole. Okay, so you can easily convert a gram of compound of the molecule, compound or molecule into mole by just dividing with molecular mass. In reverse, if you have mole and you need to convert into mass in gram, then you multiply by molecular mass. So molecular mass is the term that is necessary to relate mole and mass of compound or mass of molecule in gram. So in the case of atom, you can multiply or divide by atomic mass when you relate mole and atom in gram, mass of atom in gram. So if you are going to relate mole and mass of compound or mass of molecule in gram, then you must either divide or multiply by molecular mass. So this formula you can easily apply. Similarly, if you have number of particles, for example, number of atoms, number of molecules, and number of ions, then you can easily convert into mole by dividing with Avogadro's number. Avogadro's number, you should know that 6.023 into 10 to the power 23. So number of particles, if you are provided in the problem, then you can divide by 6.023 to 10 to the power 3 to change that into mole. And if you want to change mole into number of particles, you can see the arrow here. So mole can be converted to number of particles by just multiplication with 6.023 into 10 to the power 23. So in this way you can interconvert mole and number of particles very easily by knowing the Avogadro's number. Okay. Similarly, if you have volume of gas at entropy, you know the entropy is normal temperature and pressure. That is 760 mm of Hg pressure, 180 m pressure, and this 0 Kelvin. So volume of gas at entropy, if you are provided volume of gas at entropy in liters, then you just divide by 22.4 to get into mole. So volume can also be changed into mole, but it is only in case strictly for gases, not for other solid and liquid. So volume of gas at NTP in liters if provided, then you can easily change into mole, and mole can be changed into volume as well for the gas by multiplying with 22.4. So 22.4 is the factor that you can either multiply or divide to change into mole into volume of gas or volume of gas into mole. So in this way, mole is at the center. You can easily relate mass of atom in gram, similarly mass of compound in gram, and volume of gas at NTP in liters, and number of particles. So you can easily interconvert. Okay, you can have at least 8 formula here. This diagram gives you 8 formula. This arrow has meaning. Okay, if you want to convert mole into mass of atom, then this arrow should be seen, and this multiply by atomic mass. How much number of mole you have, then you multiply mole with atomic mass. So this is the diagram which which can be easily used to change mole into one another, like mass of atom, mass of compounds, and number of particles, along with this volume of gas at entropy. So this diagram makes you clear about how to interconvert each other. For example, if you have mass of molecule in mass of compound in gram, and if you need particles, number of particles or number of molecules, because compound has got molecules, then you have to convert first of all this thing into mole, and just by dividing with molecular mass. You divide with molecular mass, then you get mole. Gram you can change into mole first, and then you go from mole to number of particles by multiplying with this Avogadro's number. Okay, so by using this diagram, by using this case, this figure, you can easily interconvert mole and other things. So I hope that this is very useful diagram for you to interconvert mole and other. So just by, for example, if you have volume of gas at NTP and if you need mass in gram, then you have to convert that volume of gas at NTP into mole first. For that you divide by 22.4, and then once you get mole, then you multiply by molecular mass of it to change that into mass of molecule in gram. So two-step operation can give one into another. These four factors can be easily interconverted. So mass of molecule in gram can be converted into number of particles, mass of molecule in gram into mole, as well as mass of atom in gram you can easily convert into mole. Similarly, you can easily convert volume of gas at NTP into number of particles when you go to mole. And so by converting that thing into mole, first you can easily go anywhere uh, in the problem. So I just solved some problems here, typical problems, which makes you easy to calculate about mole. Okay, so let us see some examples. This is some example. We can apply this diagram to calculate the mole concept problem, numerical problem. So for example, one of the problem is uh, if you have 88 gram of carbon dioxide, then E number, find the volume occupied by it. Find the volume occupied by it at NTP. And this is in A number, and in number B, find the number of moles. Find the number of moles. Find the number of carbon dioxide molecules in it. So see here a simple problem. If you have 88 gram of carbon dioxide, okay, suppose if you have 88 gram of carbon dioxide is the compound. You know that this is a compound, it contains molecules. First of all, you need to know that whether carbon dioxide is element or compound. Surely it is the compound, and compound has got its molecule as a particle. Okay, its particle is molecule. So in the problem, okay, you have to find out in A number that first of all you need to calculate volume occupied by it, volume occupied by the 88 gram of carbon dioxide at NTP. So I have already told you that in the diagram, when you have mass of any compound and you need to change into volume at NTP, then you first of all change into mole. So first of all you need to change mole into mole, and mole of carbon dioxide equals to 88 gram. That is given. 88 gram is the given mass of carbon dioxide, and you know the molecular mass of carbon dioxide. You need to get it. Molecular mass of carbon dioxide. 88 of the molecular mass of carbon dioxide is carbon has got 12 mass and O2 has got 32. So this is 44. Okay, molecular mass of carbon dioxide is 44. So you divide with 44, and this is 2 mole. So you know that mole of carbon dioxide is 2 mole. When you say 88 gram of carbon dioxide, then you change that into mole by dividing with molecular mass, as we have seen in previous diagram. So now 2 mole of carbon dioxide has got how much volume? Then you need to multiply with 22.4. I have already told you that mole can be converted into volume by just multiplying with 22.4 factor. So 2 mole of carbon dioxide equals to 2 into 22.4 liters. So this is equals to how much? 44.8 liters at NTP. So in this way, first of all, you change that gram into mole and mole into volume. So A number you can easily do it like this way. Now find the carbon dioxide molecules in it. Carbon dioxide molecule, how much number of carbon dioxide molecule is present there in 88 gram of carbon dioxide. So we have already calculated that 88 gram of carbon dioxide is 2 mole. 88 gram of CO2 equals to 2 mole. We have already calculated it. And 2 mole of carbon dioxide is equals to, you need to multiply by Avogadro number if you want to find out particles, and molecule are the particles. Molecules are the particles of compound. So 2 mole of carbon dioxide equals to 2 into 6.023 into 10 to the power 23. This is Avogadro's number. You need to multiply it with it. So this is 3 to 6, 2 to 4, 0, and 6 to 12. 12.046 into 10 to the power 23 carbon dioxide molecules. This is the answer. So in this way you can easily convert one into another. Okay, you can easily convert this problem, mole concept problem. So this diagram is very useful. You can easily interconvert one into another. And now I solve next problem, typical problems. For example, number 2. So find the number of carbon atoms. Find the number of carbon atoms and number of electrons. Number of electrons in 16 gram of methane. This is one of the problem. Let us suppose this is a typical problem. Okay, find the number of carbon atoms and number of electrons in 16 gram of methane. So if you have 16 gram of methane, methane is the compound, you know, this is the compound, and compound has got molecule, you know it, compound has got molecules. So 16 gram of methane contains how many number of carbon atoms and the number of electrons. So at first you need to change that 16 gram of methane into mole first. So mole of methane you need to calculate, that is equals to 16 gram divided by molecular mass of methane, that is 16. This is molecular mass 16, this is 1 mole. And you know that 1 mole of methane contains 1 mole of methane has got Avogadro's number of molecules of methane. And 1 molecule of methane contains 1 carbon atom. Okay, so this much molecules of methane contains 6.023 into 10 to the power 23 molecules of methane equals to 1 molecule contains 1 carbon. So this much molecules of methane contains this much molecule of 6.023 into 10 to the power 23 number of carbon atoms. This is the answer. Okay, first of all you need to convert that mass into mole and mole into molecules. So how molecules, the number of molecules and number of carbon atoms are same, therefore this much number of carbon atoms are present. In number B, you need to calculate number of electrons in 16 gram of methane. You have already calculated that 16 gram of methane has got 6.023 into 10 to the power 23 methane molecules. Okay, that you have already calculated. And 1 molecule of methane contains how much electron? 1 molecule of methane equals to carbon has got 6 electron and 4 hydrogen has got 4 electrons. So it has got 10 electrons. 1 mole of methane has got 10 mole of electrons. Okay, you can easily calculate it because 1 molecule of methane contains 10 electrons, and 1 mole of methane contains 10 mole of electrons. That is equals to 10 into 6.03 into 10 to the power 23 number of electrons. In this way you can calculate number of electrons. So many problems you can easily solve related to mole by using this concept. So this diagram is very useful for calculation of mole. So you can calculate the mole concept numericals by using this diagram. Today I have talked to you about the mole concept. Surely I believe that it will be very useful for you to calculate the numerical problems related to mole by this diagram and this some examples. In next time I'll bring next video in next topic. For today, today I say goodbye to all of you.